As we reported to you yesterday, NJIT's solar observatory at Big Bear Lake in California is open for science again after a long and complex renovation program. Researchers expect it to improve understanding of the inner workings of stars as well as the sun's effects on everything from our power grids to our climate. Science and technology correspondent Patrick Regan gives us a deeper look at the newly improved observatory.
The sun is, of course, the most accessible star physicists can study for the advancement of pure science. And from a practical standpoint, its effects on Earth and Earthlings can be complicated and profound. Held by the sun's gravity and bathed in its light, our planet also sails through a stream of plasma called the solar wind and gets buffeted from time to time by space storms. Completed and planned upgrades to NJIT's Big Bear Solar Observatory should sharpen the scientific picture of an invisible feature, the sun's magnetic field, that's a key to understanding our star's interactions with Earth as well as its basic nature.
One problem that's vexed us for a long time is the origin of the solar wind. It's now become clear that the origin is on small scales, and the small scales are beneath what could be resolved by any other telescope but ours. We purposefully built ours not just to be the world's largest aperture solar telescope, but to be sufficiently large that we could resolve the fundamental scale of the sun's magnetic field.
With more fine-tuning yet to be done, the new telescope at Big Bear already can see features on the sun's surface that are just 30 or 40 miles across.
You know, if you think about a sunspot, it's a clustering of individual fibers, kind of like a fascia of straw. And each straw is kind of like Gabriel's horn opens up, and we can see it in cross-section and see into the magnetic field and into the fundamental scale of the magnetic field, so we can try to understand how the fields are formed and how they evolve. There are all kinds of theoretical pictures, but theoretical pictures can say anything they want as long as there aren't data to really constrain them. And so this will be a very good and profound interaction between observations and theory.
Observatory Director Phil Goody says he learned a lot more than physics from the renovation project itself, ranging from fundraising to specialty construction.
They're really interesting people, the guys who built the dome. They would spend their winters in Alaska building radar domes, and they couldn't go to work until it was 30 below. If you wonder what happened to the people whose great-grandparents, great-grandfathers were whalers, it's this kind of guy.
The result is what he hopes will be the leading ground-based solar observatory for a decade or more. Patrick Regan, NJN News, Newark.